Right, question 30, volume of revolution, again, right, and this time they're giving you this curve here. Now you might recognize this from C2 when you've got something like this, x squared and like a y squared equals r squared. It's the formula for a circle, if you remember, yeah, it's of that form. Remember it was like x minus a all squared plus y minus b all squared equals r squared. This is the circle formula, isn't it? Okay, and you've got here a circle or a semicircle, right, and this basically gets rotated around. You need to think, well, if you rotated a semicircle around, what sort of 3D shape would you get, right? And we're going to obviously answer that later, but if you try and think what you get, then you might be interested in the answer, okay, or surprised by the answer we get here. Now the volume, okay, of course, it's always pi y squared, so we write pi outside, and then what we need now is the, of course, the limits, right? Bottom limit and the top limit, and the picture here will help you, right? Because if you got x squared plus y squared equals r squared, all right, well here these are our limits. If you think about it, on these 2 points, y would be 0, wouldn't it, on these 2 points, because it's on the x-axis. So y is 0, so you end up having x squared equals r squared, which means then if x squared is equal to r squared, x then, of course, you square root, wouldn't you? You get plus or minus the square root of r squared, and square root of r squared is just r, so plus or minus r. So you've got r here minus r here. Those are the limits, right, with respect to x. Now the other good thing about this question is y squared, we don't need to do any work, because we've got this here, we can just simply say then y squared, you get it from here, can't you? It's just r squared minus x squared. You just take the x squared over. Okay, so it's really easy, okay, with respect to x. So that's what we get there. Then we're going to integrate, and when we integrate, okay, r squared, right, when you integrate with respect to x, now remember r squared is going to be a constant, right? It's going to be a certain number that r is, right? So the radius here of this circle. So it's just a constant, right? It doesn't become r cubed over 3, right? Because remember now we integrate with respect to x. So r squared is a constant, so that'll become r squared x, right? And of course x squared then becomes x cubed over 3, okay, between r minus r. And in this case, we're just chucking the numbers in, okay. So then r squared, put r in now, yeah, the upper limit, times r, take away then r cubed over 3, minus then pi, and then you've got r squared times minus r, minus then minus r all cubed over 3, okay. So this becomes pi. So in here then r squared r is r cubed, minus r cubed 3, take away then pi, r squared times minus r is minus r cubed. This then, minus r all cubed, when you cube something, this stays as a minus, right? So it's still going to be minus r cubed, but you've got a minus there as well, so that becomes plus r cubed over 3. So then you got, right, r cubed take away r cubed over 3, right? So that's like a whole take away third, so it'll be 2/3 r cubed, take away pi, minus r cubed plus r cubed over 3. This is like minus a whole plus a third, so it'll be minus 2/3 r cubed. Okay, so then this becomes 2 pi r cubed over 3. And then you go minus then pi times minus this, so 2 minuses make a plus, and that'll be 2 pi r cubed over 3. And then if you put them together, bottom numbers are the same, so you get 4 pi r cubed over 3. Now give a geometrical interpretation of your answer. If we remember back to GCSE, this is the volume of a sphere. Okay, that's what happens when you rotate that semicircle around, with, of course, radius r. Okay, so you need to mention that the sphere's got a radius r.